Do you think that man is the master of creation whose brain knows no bounds? That's a very big mistake. The speed of light in a vacuum is one of the numerous barriers which have not been overcome by humans yet. The maximum speed attained by 3 humans is about 40,000 kilometers an hour. They were astronauts from the Apollo 10 mission. There is no doubt that a century ago, these figures would have caused a furor. But modern humanity has another, more ambitious goal. You might ask, which one? 1 billion kilometers an hour? These very figures are hidden in the sacramental expression, speed of light. Right now, they are only possible in the pages of science fiction books and NASA software. But what pitfalls are lying in wait for enthusiastic scientists on this thorny path? Problem number 1. Speed. Today's pathetic attainable speeds will take the Voyager space probe, which has recently moved outside the solar system, to the relatively close Aldebaran system in only 2 million years. In the conditions of present-day engineering development, and at most hypothetically possible speeds, it would also take people of Earth several thousand generations to get to Proxima Centauri, the nearest star located at a distance of about 4.5 light-years. To compare, in particular conditions, an ion engine moves at a speed of up to 56,000 kilometers an hour, which means that it would take a ship with such an engine 81,000 Earth years to get to Proxima Centauri. During this time, 2,700 generations will have changed on Earth, thus making this trip almost senseless. In the case of a gravity-assisted maneuver, the maximum speed can be about 240,000 kilometers an hour, which is just a fraction of the speed of light. Voyager would get to Proxima Centauri in about 19,000 years at such a speed. Doesn't sound that inspiring, right? But if we imagine that a ship able to fly the speed of light has already been built, the forecasts are quite sad. It would take this vessel tens of thousands of years to fly around our Milky Way, which is 100,000 light-years in diameter. And how long would it take to fly to the neighboring Andromeda galaxy, separated from us by a distance of 2.5 million light-years? Moreover, we should take into account that we see the galaxy the way it looked many millions of years ago. It is possible that this galaxy does not now exist at all, and the only thing left from the nebula is the light that has reached Earth. Problem number 2. Ship. Now, it is absolutely impossible to build a spaceship that could even come close to the speed of light. There is neither the fuel nor materials. Huge overloads faced by a shuttle in deep space require extra strong materials, unreal sizes, and revolutionary new fuel. For example, in order to use thermonuclear reactions, a ship has to be the size of a small planet, weigh as much as the moon, and be full of dangerous cargo, fuel. It is impossible to build such a monster in orbit, and all the more on the Earth's surface. And if we try to make a small shuttle move at the speed of light, it will take as much energy as the Earth generates for an entire month. Scientists have thought about using antimatter. An engine using such fuel can accelerate a ship to a speed constituting 70% of the speed of light. But this method creates even more problems. Firstly, the process of annihilation, the interaction between matter and antimatter, creates huge radiation, and all organisms on board such a ship would die. Secondly, there emerges the problem of fuel storage. The smallest contact with the ship would lead to a terrible explosion. Thirdly, the creation of antimatter is a very costly affair, and its result is very non-durable. 1 milligram of positrons costs $25 million and exists for about 20 minutes. Desperate scientists also have strange ideas about the creation of an artificial human world inside an asteroid, which would fly in space for many tens of generations to the nearest star by revolving around its axis. Yet, there is a risk that in several thousand years, people would forget about their purpose and place of destination, and wouldn't even remember who they initially were. And the story about traveling to the star would turn into another legend. Problem number 3. Violent space. Unlike the likes under this video, a vacuum is not empty at all. In the conditions of light speed, its particles turn into a deadly threat for an intergalactic Voyager. Even at a speed of 20% of light, hydrogen and space dust atoms will severely bomb a spacecraft body. And the speed of light will simply kill the vessel together with its crew. The strength of impact will be comparable with a proton beam accelerated using the Hadron Collider. There is no material able to withstand such impacts, even in theory. Hypothetically, it is possible to build a screen protecting the ship against bombarding and lethal radiation doses. But this screen has to be several hundred meters thick and weigh several hundred tons.
Light has surrounded us since the very ancient times. Centuries before, at night, people burned tallow and wax candles in the rooms, and outside a light was provided by bonfires and the moonlight. After the incandescent lamps appeared, the night towns and villages lit up like Christmas trees. You've probably noticed that now in many big cities at night time, everything is quite visible as during the day. But the evolution of the devices that give light to humanity hasn't affected its physical properties in any way. The basis of the phenomenon is still specific elementary particles, photons. They transmit all kinds of radiation, including visible light. So, thanks to these particles, we observe distant stars and galaxies, as well as light up our houses. To demonstrate the photon's property, you need to go to deep space. Its vacuum is a pure heaven for these tiny particles. There they can cover millions and billions of light years distances without colliding with anything. So, what are the characteristics of photons? The photon has no mass and no energy. They don't have dimensions and are able to move at boundary speeds. In particular, in a vacuum, they cover 300,000 kilometers distance per second, but in a transparent environment, photons are much slower. For example, getting from the solar core to the corona will take the particle about 1,000,000 years, while at the same time it will reach the Earth in 8 minutes as soon as it gets into outer space. The photon is the most common particle in the macrocosm. There are 20 billion photons per proton or neutron. There is no time for them, as these particles are almost eternal, but the photon's life lasts for an instant. It lights up and immediately gets absorbed. Many people wonder where photons go when a star dies, a galaxy goes out, or a light bulb turns off. For example, the light emitted by the ancient stars when they still existed reached human eyes only billions of years later. That means that now we see the light of the stars that are most likely long dead. But the sun, as you know, dies long and spectacular, just as you also know that an ordinary light bulb turns off quite simple. You click the switch and the room goes black. But where do the photons that the lighting device emitted fractions of milliseconds ago disappear? Let's turn to science. At the moment when you turn on an incandescent lamp, or any other kind of it, it begins to spread millions of photons randomly moving around. According to the law of physics, after that particles have two options: either be reflected or to be absorbed by other objects. Thanks to the first phenomenon, we are able to see objects around us and see ourselves in the mirror. It's important to understand that when reflecting, that is, colliding with an object, photons lose some of their energy potential. But during absorption, the surface usually gets heated as it absorbs some of the particles. In practice, this appears as follows: warm park benches in summer, hot pebbles on the beach, hot stones in the desert. The process that occurs after the lamp is turned on is based on these phenomena. Photon streams are reflected from other objects or eventually absorbed by them. When we turn off the light bulb, new photons stop entering the room and the old ones don't disappear. They continue to collide until each particle finds an atom that will, roughly speaking, eat it. You may come up with a reasonable question: Why does the light not go out gradually if the remaining quanta are still in the room? If you think about it a little, you will come up with the answer by yourself. For photons, the concept of some time is equal to what is an instant for humans. The fact is that unique particles are reflected and absorbed in millionths of a second, so we just cannot grasp the true moment. For the observer, there are only two states, before and after pressing the button. Photons, on the other hand, experience a whole adventure during this time. But quanta of light surround us not only when we light a chandelier or a reading lamp, but literally everywhere. Daily Wi-Fi, pizza heated in the microwave, radio signals from the headphones, laser scalpels that help people get rid of terrible diseases, as well as powerful gamma-ray bursts that can sterilize everything around for many millions of kilometers. All this is a collection of photons. But if the ephemeral particles lose energy in collisions or while moving for a long time, then how do we see the light of the stars and galaxies? But who said that we see all the objects without exception? If we had, then the night sky would seem as bright as day. However, we can only see the bodies that emit the most powerful photon stream. Such a ray can cover billions miles distance. As the power decreases, the distance at which the light ray completely loses its energy and ceases to be observed also decreases. We also cannot see space bodies that are too far away, because the light gets scattered and photons are lost over vast distances, colliding with planets and other bodies, either losing energy or being absorbed by them. Basing on this statement, some scientists have deduced a whole theory stating that the universe is actually stationary and it can't expand, and the Doppler redshift is due to the effect of photon energy loss, not the rate of their removal. All of this, of course, controversial and practically unsubstantiated, but it has the right to exist. So, the particle connecting our drab everyday life with the space is discovered. Well, now turning on the light bulb, some of you may try to catch photons literally on the spot, but it's worthless. But seriously, the fact that there are fundamental particles from the boson family is one of the best news for all of humanity and the universe as a whole. Otherwise, an utter darkness would have been the only thing there were. The stars are now lighting up.
The observable universe has an area of about 90 billion light-years. We can assume that the unobservable part of the universe might be much larger. The cosmos is so immense that the human mind simply can't comprehend it, at least not yet. However, some theories say it may turn out that the cosmos is much smaller than we think. How can that be? Welcome to the Hubble channel. Today we will try to guide you along the bridge connecting the macro and microcosm. According to modern data, the observable part of the universe may have a diameter of about 20 trillion light-years. Just imagine it. Based on the available data, we can assume that most of the outer space should be empty, because there is no much matter in our part of the explored cosmos. Looking into space, we will see giant, boundless expanses of the icy void. But what if the universe fits in one atom? Sounds absurd? Don't be skeptical. This theory might not be all that incredible, though it's more like philosophical fiction. But first, answer a question. Do you remember what you know about matter? Any matter consists of the smallest particles, which are called atoms. These babies are the basis for the universe in the usual sense. Atoms are so small that we cannot really see them using even the strongest optical devices. In fact, we cannot even know with reasonable certainty what exactly an atom looks like. We can only assume this based on scientific theorizations. Although we cannot see atoms, it is considered proven that atoms consist of smaller subatomic particles, such as neutrons, protons, electrons, and quarks. Nowadays, it's already known for certain that atoms are so numerous and small that the body of an average adult consists of approximately 7 octillion atoms. Let's remind that this figure can be represented as the digit 7 with 27 zeros. Just try to imagine this number. But an atom, in turn, also has its complex structure, and it allows us to think about the incredible theory of the micro-universe. What does an atom look like, so to say, from the inside? From your school chemistry course, you probably remember that an atom consists of a nucleus, which is formed from protons, neutrons, and electrons moving around it. This model was proposed by Ernest Rutherford in 1911 and was called the planetary model of the atom. Indeed, you can see the analogy, because the movement of atoms around the nucleus is very similar to the movement of planets around the Sun. Moreover, this model hasn't been rebutted and is even confirmed by modern research, clarifying that the motion of electrons should be described by the laws of quantum mechanics and not classical. Is that to say that the smallest particle, the basis of matter, has a similar structure with neither more nor less the solar system? Could this be a simple coincidence due to the laws of physics, or is this similarity something much more fantastic? We'll return to this issue in a minute, but for now, try to answer the question: how many electrons are there in our universe? The question sounds absurd, doesn't it? Neither the most powerful computer nor the human brain can handle such a number. But what if I told you that there's only one electron? The interpretation of one electron universe postulate was offered by the American physicist Richard Feynman, and it all sounds like pure fantasy. The hypothesis says that actually all the same electron moves in space and time so quickly that it seems to us that there are a great many of them. Just one particle gives shape to everything that we consider to be the whole universe. How about that? Of course, this theory didn't find many supporters. But what is funny due to the principle of the identity of electrons and the possibility to experimentally distinguish one electron from another, the theory cannot be refuted. How's that for a paradox? But let's go back to the structure of an atom and those incredible theories. Let's try to answer the question: what is the size of an object? Although the meaning of this word is domestic and familiar, actually the concept of size is rather mysterious and relative. For example, the world around us is adjusted to our size because it was built by us, but if we consider natural creations, everything is far from so simple. The mountains and planets are so huge for us that it is impossible to comprehend them. But we consider small ants as well as all microscopic life forms. But do ants consider themselves small? Do they understand that they live in the world of giants? It's unlikely that their world is as familiar to them as our world is familiar to us. Comparing with space objects, we're not even microscopic. We're talking about even smaller values. This idea makes our skin crawl, and no surprise why. No wonder the great master of horror and fantasy Howard Phillips Lovecraft in his works promoted the idea of the insignificance of humanity in front of the face of the endless space. And here we come to the main issue of our video. What if our universe can fit on the tip of a needle? What if the solar system is just an atom, one of the myriads of the same, which are part of some other matter? Based on this version, it's logical to assume that the atoms and particles that make up our world can also contain worlds inside. As one wise man said, the limit doesn't exist, does it? Yes, as a matter of fact. Our reality may indeed be at the subatomic level of the completely different reality. Likewise, other worlds can be located on our subatomic level. And so ad infinitum, decreasing and increasing the scale. Sounds incredible, but we're here to explore the incredible. The most interesting is that looking at the known universe and observing the laws functioning there, we can easily come to the same conclusion. Everything starts with the smallest particles, like an atom, and ends with colossal celestial bodies and star clusters. Everything in our world, starting from your lunch today to some recently discovered exoplanet, is made of the same building block. The dream of the scientific world is to find a theory of everything. The question of the ratio of the micro and macrocosm is the most important building block in this theory. By reconciling quantum mechanics and classical physics, generations of young scientists may be able to understand the true nature of our universe, and even what goes beyond it. After all, even according to one of the most popular versions of the origin of our universe, it all began as an infinitely dense and at the same time a small singularity. Later, the small point spread to all known limits. This is called the Big Bang Theory, a transformation from something small to something bigger. Do you also think that this is quite consistent with what we have talked about the micro and macrocosm today? Yes, but there is also an important note. A point is not equal to an atom. Despite its small size, the singularity that caused the Big Bang contained everything necessary to build the entire universe, and it's still impossible to say that it originated from one atom. There's also the so-called string theory, which is a great candidate as a theory of everything. The general idea of this incredibly complex theory, which has many interpretations, is that an atom is not the spherical object, whose shape and appearance we remember from school, but rather something like strings. The relationship between these vibrating strings includes almost everything known to science. The laws of classical physics, including gravity and quantum mechanics. But there are also weak points in string theory. It explains a lot, but begins to stumble. For example, on dark matter. In this case, string theory begins sagging. But say no to pessimism. Scientists have been struggling for a long time to integrate the theory of dark matter into string theory. At the end of 2018, Swedish scientists published a new version of string theory, according to which our universe exists on the edge of an ever-expanding bubble. This version brushes aside the 4 dimensions which are familiar to us, 3 spatial and 1 temporal dimension, and it invites us to consider our entire universe as just vibrations on the surface of this bubble. That what happens inside the bubble, or at the distance from it, remains a mystery. How about these prospects? We're just one small civilization, a point in a small piece of reality located on the surface of a bubble, which in turn can be a part of something much larger. Many of you would agree with the statement, fish like the bottom deeper and flatter, man also looks for what is better. This rule applies not only to people, but also to the planets. Some of them are absolutely dead and deserted, while others have necessary potential for the origin of life. For example, our hospitable Earth. What determines the chances of any planet to become comfortable for the development of intelligent and highly organized forms of life? Will we ever learn about the existence of alien life, or it simply does not and cannot exist? Was the origin of life on Earth the result of a chain of unique accidents that are unlikely to be repeated on another planet? Does any specific place matter for the origin of life in space? Let's try to figure it out today. Why various planets have so different conditions. The surface of some planets is hot and saturated with poisonous vapors. The other ones are so cold that any living being would instantly turn into ice there. Obviously, in addition to the composition of the planet, it also depends on the location of the planet in the galaxy relative to the stars, as well as the stars that are near the planet. The area of space where the planets can be potentially habitable is called the habitable zone, or it is sometimes referred to by another name, the Goldilocks zone. The fairy tale tells us about the girl who had to use objects one by one and only single object of each set was usable. The rest turned out to be either too big or small, hard or soft, and only something in between fit perfectly. Haven't you understood how a fairy tale could be related to the possibility of the origin of life on different planets? It has a direct relation. After all, each planet can have only one perfect place, not too far from the star, but at the same time not too close. What are other factors that affect the planets? Let's try to figure it out. Some scholars believe that planets located in special regions of large galaxies may be the most suitable for life. These areas are called galactic habitable zones. We will talk about them today. What constitutes such a zone, and what mandatory conditions does it imply? The concept of a galactic habitable zone has been criticized more than once due to the inability of scientists to fully assess the factors that turn individual places of the macrocosm into potential oases of life. Besides, some stars often have unstable orbits over long periods of time, which periodically causes shifting of the habitable zones. Nevertheless, such locations in space do exist, and we live in one of them. Many scientists such as Harlow Shapley, Jim Clark, Wallace Tucker, as well as many other astrophysicists, paleontologists, biologists, and astronomers worked on the development of the theory of a galactic habitable zone at different times. What factors contribute to the emergence of acceptable conditions in certain regions of the galaxy? The most important, as we have said before, is the location next to the correct star at the correct distance. In other words, the planet should be located not too close so that the star doesn't burn out the surface with excessive radiation, as it happens, for example, with Mercury. The nearby sun prevents the planet from forming a dense atmosphere, and at the daytime the surface heats up to almost 800 degrees Fahrenheit. The planet shouldn't be also too far from the star, so as not to turn into an icy desert like Uranus and Neptune. The star is also very significant. Astronomers have concluded that the planets that are outside the solar system, so-called exoplanets, are more likely to appear near young high-metallicity stars, which contain elements heavier than helium and hydrogen. But it is important to maintain a balance here. The unbalanced number of elements will cause giants to appear instead of Earth-like objects, knocking the planets out of their orbits and committing other atrocities. Nearby supernovae, for example, have the potential to severely harm life on a planet. With excessive frequency, such catastrophic outbursts have the potential to sterilize an entire region of a galaxy for billions of years. After we have learned the main parameters of safe zones in which life might most likely develop, you probably have a natural question. Where are these zones located, and what do they look like? According to the available data, the galactic habitable zone is commonly believed to be an annulus-like region located in the center of the galactic plane, and the size of this ring can vary and change. What are the dimensions of the chubby ring? According to research conducted in 2004 by Lineweaver, the Goldilocks zone across the Milky Way is located at a distance of 4 to 10 kiloparsecs from the galactic center. Other researchers cite data from 2.5 to 15 kiloparsecs. But these are not the final figures, since many factors influence the narrowing or expansion of the favorable sector, including unpredictable cosmic catastrophes that inevitably shake the black spaces of the macrocosm. Why is the study of space habitable zones so important? First of all, this study can provide answers to two most important questions for mankind. Does life on other planets exist? Are there Earth-like planets that someday in the future may become a new home for Earthlings? These questions are rather complex because everything related to space is quite fragile and subject to its own laws. For example, supernova explosions we have talked about are dangerous for existing planets, but at the same time they help to create new ones. Their waves spread heavy elements throughout the universe, creating new stars and planets on their orbit. You see how complex and subtle everything is. It's bad if there are no supernovae emitting their apocalyptic gamma-ray bursts, because no new space objects will appear. It's also bad if supernova activity is too high, because any potential life on nearby planets will be destroyed. The abundance of such nuances and subtleties, which is quite numerous, gave rise to the so-called rare Earth hypothesis. This is the variant of the answer to one of the age-old questions that Earthlings have been asking since they first began to explore space. Why hasn't a single trace of extraterrestrial life been found in the universe, which is many billions of years old? Are we really alone in the universe? The rare Earth hypothesis tells us that yes, we are. The creation of the Earth in the form which allowed the first life to originate, evolve and take intelligent forms is a chain of such unique accidents that it is unlikely that something like this can happen again, just according to the theory of probability. We will analyze in detail this interesting but slightly pessimistic theory in the other videos. But for now, let's just say that it has been criticized a lot. And moreover, a large number of exoplanets that were discovered in the Goldilocks zone proves that we may be just not unique at all. What did the scientists manage to find? On March 6, 2009, Kepler, a NASA astronomical satellite designed specifically to search for exoplanets like our Earth, was launched. The satellite was equipped with a super-sensitive photometer and was created specifically for this purpose. It was designed for 3.5 years of operation, but worked a little longer, failing only on May 12, 2013. Kepler has managed to serve mankind a lot by transferring sensational data to scientists, so over the years of work, it managed to discover more than 3.5 thousand potential planets, which more than 1,000 of them have been confirmed by various scientific groups. Moreover, some of these planets are as big as the Earth. Who knows what we'll be able to find on such planets if we fly to them on a research mission? Perhaps extraterrestrial dinosaurs, or maybe people who haven't yet reached the level of space exploration. What do you think? Can numerous extraterrestrial civilizations exist within the Milky Way simply not paying attention to Earthlings? We find ourselves at a truly historic time, and we're witnessing many events which will certainly be included in history books. We used to think that something bad is hiding behind those words, something like wars or pandemic that has been spreading around the world for more than a year. But one of these days there was a historical breakthrough and a huge step forward for all mankind as a whole, and a field of space in particular. February 18, 2021 has become a truly significant day. What has been followed by millions of people for 6 months has been successfully completed. The Perseverance rover has finally completed the journey to the surface of the Red Planet. And on that day at 12:55 p.m. Pacific Time, everyone was finally able to breathe a sigh of relief. We can rightfully call Perseverance the heart of NASA's Mars 2020 mission. The super rover launched on an Atlas V rocket from the coast of Florida on July 30, 2020. The rover managed to accurately land in the Jezero impact crater, located in the west of the Isidis Plain, near the eastern edge of Syrtis Major. It's interesting that in that era on Mars, the crater was a lake when a system of river valleys was forming. The name Jezero is translated as a lake. This word is present in many Slavic languages, such as Serbian or Slovenian. The rover received the name Perseverance. The name was chosen and named the rover National Student Essay Contest organized by NASA. This wonderful and proud moniker was born in the essay of Alexander Mather, at the time a 7th grader at Lake Braddock Secondary School in Burke, Virginia. Perseverance is a strong word. Thomas Zurbuch, an associate administrator of NASA Science Mission Directorate, said in March 2020 during the rover's naming ceremony. It's about making progress despite obstacles. The launch of the rover has already become an amazing demonstration of that very perseverance and ability to avoid obstacles. I hope you remember that getting to Mars is not so easy. And it's not just about distance. There's a so-called window of opportunity, the moment when the distance between Earth and Mars is reduced to a minimum. Such windows suitable for missions to Mars only appear every 26 months, so NASA decided to get the rover off the ground in time. This is a very daunting task, and it was even more difficult because of the coronavirus pandemic, which forced to review the hardware assembly, testing protocols and team safety. You know what? They managed to do it. The rover has successfully landed and has even sent two color images from the surface of Mars. The first image is a selfie of the wheel. The second one is the surface of Mars, which turned out to be rather gray, not red. NASA also published a video of landing of the Perseverance rover on the surface of Mars and the first 360-degree panoramic image. Why is Perseverance so important to us, since this is not the first rover to visit Mars? Why is it so unique? And what great mission was it assigned? The groundbreaking rover was developed by NASA Jet Propulsion Laboratory, and no doubt this rover is the most advanced and modern machine that has ever been created on Earth. It has a truly unique set, which will allow performing very ambitious and important tasks for the subsequent exploration of Mars. After a series of tests, the rover will hunt for signs of ancient life on Mars, collecting and storing rock samples for future return to Earth. One of the main tasks is to prepare for the future landing of astronauts and test ways to obtain oxygen on Mars. The rover also helped to improve landing techniques, to accurately define weather conditions on Mars, and more. Perseverance will scrutinize Martian rocks using a variety of high-tech scientific instruments, including numerous spectrometers, high-resolution cameras, and ground-penetrating radar. One of the rover's 7 instruments, called SuperCam, will zap rocks with a laser and gauge the composition of the resulting vapor. Using a drill at the end of the long robotic arm, Perseverance will collect about 40 samples from highly promising areas and seal them into special tubes. Possibly as early as 2031, this material will be delivered to the Earth as part of a joint NASA and European Space Agency campaign. An unmanned robotic aerial vehicle named Ingenuity was also found to be a breakthrough innovation. This drone is equipped with cameras and will perform a reconnaissance mission, flying around Mars and transmitting accurate and high-quality images. Like other NASA rovers, the 6-wheel Perseverance is largely based on its predecessor, the NASA Curiosity rover, which landed on Gale crater on Mars in August 2012 and is still going strong today. But it has some amazing innovations, discovering completely new opportunities for humanity. Perseverance is several inches longer than Curiosity, and with weight of 2,260 pounds is almost 300 pounds heavier. The sets of scientific instruments of the two rovers also differ significantly. These two rovers have the same basic design and the same type of nuclear power source. They also use the same strategy to land safely on the Red Planet. Do you like numbers or statistics? I'm sure that normally you would say no. But we shouldn't miss unique indicators of Perseverance. Curiosity's specific strategy for getting rovers to Mars sounds like something out of science fiction. Perseverance slammed into the atmosphere of Mars at a speed of 12,100 miles per hour. And in several minutes it ejected a 70.5-foot wide parachute, continuing to move faster than sound. But Mars air is just 1% as thick as that of Earth, so a chute couldn't slow the rover down enough for a safe landing. Mars 2020 therefore employed a rocket-powered sky crane, which lowered the Mars car to the red dirt on cables, then flew off to crash land intentionally a safe distance away. To everyone's delight, NASA received word that Perseverance had gotten down safely at 12:55 p.m. Pacific Time, about 11 minutes after the landing actually took place. It currently takes that long for signals to travel from the Red Planet to Earth. The news prompted wild celebrations at the Jet Propulsion Laboratory in Southern California, which manages the Mars 2020 mission. There was doubtless a decent dose of relief mixed with the excitement, for success today was far from guaranteed. Over the decades, only about half of Mars surface missions have touched down safely. And Perseverance's landing site on bottom of Jezero, which features hazards such as cliffs, sand dunes, and boulder fields, was the toughest ever targeted by a Mars mission. The rover's landing ellipse was just 4.8 miles long by 4.1 miles wide, compared to 4 miles by 12 for Curiosity. Perseverance hit the target today with the aid of two new entry, descent, and landing technologies that Curiosity didn't have at its disposal. One, called Range Trigger, allowed the mission to deploy its supersonic parachute at just the right moment. The other, Terrain Relative Navigation, enabled Perseverance's sky crane to assess the Jezero landscape and navigate autonomously around potential hazards during the descent. The landing technologies worked exactly as planned, guiding Perseverance to a picture-perfect touchdown on a safe and flat part of Jezero's floor. And the rover seems to have made it through all challenges in fine shape. Perseverance has already beamed home its first images of its new surroundings, and initial health checks and onboard system tests revealed no causes for concern. Curiosity was once created to access the habitability of Mars, and that rover has found plenty of evidence that Gale Crater could have supported Earth-like life billions of years ago. Perseverance will take the next step in this direction. Jezero is a great place to do such work, mission team members have said. The crater, which lies about 18 degrees north of the Martian equator, hosted a lake the size of Lake Tahoe long ago, and also an ancient river delta. Besides, Mars orbiters have spied on Jezero's floor clay minerals, which form in the presence of liquid water. Do you remember at the beginning of the video we asked, what is next? As it turns out, we will discover many interesting things. Once on Earth, the samples will be studied by hundreds of scientists for decades to come. Researchers are still poring over the moon rocks hauled home by NASA's Apollo astronauts half a century ago. Bobby Braun, director of Solar System Exploration at Jet Propulsion Laboratory, said during a pre-landing news conference on February 17th. Have you ever hoped that you would see Shakespeare's Fairy Queen from the comedy A Midsummer Night's Dream looking through a telescope? Meanwhile, it's quite possible. The modest gas giant Uranus is worth paying attention. It has a host of various satellites around. One of these satellites is Titania. For the first time, an earthly observer saw this huge and icy moon in 1787. William Herschel, astronomer, was the first to discover it. He was the only one to observe Titania for the next 50 years. So the quiet and frozen moon, what is it like? Which one of the earthly automatic probes dared to visit its surroundings? The only one who saw the planet firsthand was Voyager 2 in 1986. Not a single interplanetary station has ever flown into this location, and in the near future, no flights to the Uranus system are considered. What did the fearless probe manage to find out? By virtue of the exploration of the Pioneer Voyager 2, we'll learn that Titania is the largest satellite of Uranus with a diameter of 1,577 kilometers. The reddish-brown planet orbits 436,000 kilometers from the smoky turquoise giant. The general area of the surface of Titania is 7.8 million square kilometers. This moon is constantly turned by one side to the parent celestial body, and 1 year on the satellite lasts the same time as 1 day, which makes about 9 Earth days. Titania is influenced by the magnetosphere of Uranus, so active plasma particles regularly and continuously bombard its surface. We believe that the hemisphere facing the giant has a darker hue for this reason. Neighborhood with Uranus gives Titania incredibly long periods of summer and winter. Each one lasts for more than 4 decades. This means that during 42 years, one of the poles is immersed in darkness and the other is full of light for the same period of time. This strange world is most likely very cold. We could assume that during the summer solstice, the temperature on the satellite's surface doesn't rise above 300 degrees Fahrenheit below zero. The crust of Titania is solid water ice. In addition, the half of the crust are stone inclusions and possibly organic matter. Of course, there are some chilling secrets in the Voyager 2 mission. It's possible that between the core and the mantle of Titania, there's a subglacial water ammonia ocean. Although there's no exact information about this yet. If the water body does exist, it could be 50 kilometers deep, and its temperature could reach 117 degrees Fahrenheit below zero. It's possible that after the incredible ocean had been frozen, the crust of Titania subsequently cracked, which increased the surface by 7%. What else should we mention when talking about this satellite? The largest and most massive moon of Uranus is a world of vast valleys, ledges, and deepest craters. The planet's surface is quite young, which indicates that it has been renewed recently. Despite the fact that geological activity somewhat combed and smoothed the satellite's body, it still has one impressive scar. The largest known crater of Titania is called Gertrude. You can see it in the upper right part of the image. It is a funnel with a diameter of 326 kilometers and a central hill 150 kilometers wide, towering 3,000 meters above the monstrous pit. This is the largest impact crater of those that cover the surfaces of 27 Uranian satellites. But this type of terrain is not the only one. There are grabens on Titania, which are 50 kilometers wide and up to 5 kilometers deep. That means that if the observer were on one side of the fault, he would not even realize that he is standing next to the canyon. In order to do this, he would have significantly rise above the surface of the Uranian moon. One of the most prominent among Titania's canyons is Messina, which runs for about 1,500 kilometers. Compared to it, the terrestrial Grand Canyon is a minor notch, which is not worth attention. The slopes of Messina are covered with water frost. It is evidenced by polarimetric data. The spectrograph has found light deposits around craters and faults, which has different porous structure. The astronomers have concluded that this is what's commonly called frost. In general, the landscape of Titania is the result of a tough confrontation between endogenous factors, such as cryovolcanism and external impact effects. There are only 15 craters, 2 canyons, and 1 ledge on the map of the satellite. But there are more of them on the planet. Therefore, our descendants will most likely give names to so far unnamed ruts and cliffs. It's easy to notice that the name of the relief objects discovered on the satellite of Uranus entirely relates to the works of great William Shakespeare. The Merchant of Venice, 238-kilometer Belmont Canyon and 64-kilometer crater Jessica. Hamlet, the Titanic crater Gertrude, Antony and Cleopatra, 33-kilometer long crater Iris, and others. What's also interesting, Titania has the atmosphere. But don't be excited too early. The atmosphere here is extremely weak and thin. It's present only in certain seasons and is prone to migrating to the shaded poles. The air of the satellite mainly consists of carbon dioxide. Nitrogen and methane are too light to be found in the ghostly atmosphere of Titania. These elements will instantly drift into space. 30 years ago, Voyager 2 approached 365,000 kilometers to Titania, but explored only 40% of the surface. Meanwhile, only slightly more than half of the indicated territory could be mapped. The detailed study of the surface of Titania was hampered by the fact that one side of it was in deep shadow, so it couldn't be explored. If you looked at the sky of Titania, you would see Uranus ringed with thin, barely noticeable hoops. As we have already mentioned, the satellite never turns to the planet with its reverse side. It's easy to guess that the gas giant has forever settled in the sky of Titania, while the opposite hemisphere has never seen its formidable neighbor. Let's think what will happen if someone suddenly comes up with the idea of organizing a manned mission to the largest Uranian satellite. Desperate travelers will have to understand a simple truth: the planet is extremely inhospitable. There's severe frost on it. The rugged surface is full of hellish faults and deep craters. The radiation background is off-scale due to the proximity of Uranus, and the change of seasons is so rare that there's a possibility to die until next summer. The one consolation to the absence of the atmosphere on Titania is that there are no destroying hurricanes with speeds up to 300 kilometers per second, as they are in Uranus. Besides, it has a solid surface, unlike its gaseous neighbor, where an alien wouldn't be able to take a seat or even stand. Let's look at this beautiful but harsh moon once again. At least we have the eyes of one of the voyagers. It's very sad to contemplate, but our interest of the conditions on Titania is purely theoretical, because not only astronauts, but also automatic probes will not visit the distant planetary system in the near future. Therefore, at the moment, you have a great chance to become famous and self-actualize by offering your own author's project of the mission to Titania.
Imagine a situation. You come home and decide that it's time to change something. So you violently break the furniture, throw the contents of the trash can on the floor, stop washing dishes and clean the toilet, and to top it all off, turn on the gas. The system is broken, but can such actions be called reasonable? Humanity behaves in relation to its global home, planet Earth. In much the same way, it destroys the animal world, litters incredibly, pollutes the atmosphere, depriving it of the ozone layer. Given the ability to regenerate, the long-suffering planet that sheltered Homo sapiens lasted as long as possible. But recently, it more and more often hints that we are staying here for too long. Where to find a new home? Should we hope for a mission to colonize Mars? Yes, it has been planned for a long time, but the red planet is not Earth's twin, so the difficulties of migration can be insurmountable. Is there a celestial body on which it is warm enough and not too cold? Ocean splash, an atmosphere similar to that of Earth? Where can we find the cradle of future life of humanity? Attention to the constellation of Taurus. The Kepler telescope in March 2018 discovered in this location an object that supposedly has almost the same characteristics as the Earth. By a strange coincidence that has developed recently, the planet under the code name K2155d is located next to a red dwarf, a rather calm but dim long-lived star. A double of Earth has been discovered in the company of 14 other planets, but the conditions on them are unlikely to seem comfortable for the emergence or maintenance of life. The climates and temperature parameters of these objects are unfavorable, if only because their distance to the Sun is too small. The year on each of them does not exceed 40 Earth days. In such cases, tidal forces act and the planets, being unable to turn away from their star, are constantly fried on the side. This means that on the illuminated surface, there is a hellish heat similar to that of Venus, and on the dark surface, there is cold and darkness. But there is hope. If at least one of these planets is shrouded in a dense atmosphere, then the situation will change. Due to the distribution of heat, the temperature in both hemispheres is relatively stabilized, although this will cause a hurricane of unprecedented strength. And yet, many astronomers do not believe in the existence of adequate conditions for the start of evolutionary processes on planets that circle too closely around red dwarfs. The absence of a magnetic field and strong flares from the star make the development of life on celestial bodies unthinkable. Despite the longevity of such celestial bodies, all this is true, but not for K2155d. According to Japanese scientists, a planet similar to Earth is located in the Goldilocks zone, so the formation of life on its surface is quite likely, although it probably looks at its star one-sidedly. The object contains 3 Earths and is 200 light years away. It is still difficult to study the celestial body in more detail, but NASA has planned a mission designed to clarify the conditions on 15 discovered planets including K2155d. Let's try to imagine what we can expect in this distant unknown world. What if astronomers made a mistake in their calculations and the conditions on the planet are completely different from what is supposed to be? Waterless world. Imagine K2155d as a celestial body on which the water is as hard as diamond, and rivers of liquid methane flow along the ancient channels, simultaneously forming poisonous lakes. It could be a dirty, foul-smelling frozen world in which, in theory, only methanogens, creatures made up of cells based on nitrogen compounds, will survive. Not a very tempting picture. Not life but flint. It is possible that K2155d is seriously hot and its atmosphere is solid hydrogen with minor impurities. Suppose that in this infernal world, there were attempts to form life and the trace element from the periodic table silicon, which is part of many terrestrial rocks, replaced carbon, becoming instead the basis of evolution. In the same way, arsenic could take the place of phosphorus and sulfur successfully displaced oxygen. In this case, alternative biochemistry can lead life into labyrinth, and when the astronauts finally landed on the surface of the planet, they would be met by hot lava and extremophile. Such a hot welcome is also not comforting. But let's forget about the exotic methanogens and extremophiles. If, after all, the conditions on K2155d meet expectations and are at least somewhat close to Earth's, then once they reach its surface, the astronauts will see an unusual world. They will be met by absolutely black vegetation, which over centuries has adapted to more efficient absorption of the full light spectrum and thus optimized photosynthesis. Perhaps the plants on K2155d have got filters that protect them from the radiation periodically emanating from the parent star and also increase the volume of the root system so that the most severe storm does not carry them away. On the side that is always turned towards the sun, people will see a huge ocean, land and mountains illuminated by a ghostly reddish light. Due to the fact that the sun never sets in one hemisphere, the shadows cast by rocks and vegetation will remain unchanged for centuries. According to convergent evolution, and conditions similar to Earth's development should take place according to a well-known scenario, so it is possible that the aliens will meet even animals on K2155d, small and completely deaf due to the fierce wind. Scientists believe that if the planet is inhabited, then most likely it will not be completely covered by the ocean. After all, in this case, all the substances necessary for the course of chemical reactions will be buried under the thickness of the liquid. Anyway, the celestial bodies circling near red dwarfs are definitely candidates for a potential registration of humanity. Who knows, perhaps a century later, our descendants who are not at all like today's people will watch their blood-red sun, which never goes beyond the horizon, occasionally remembering the Earth, a planet that has long sunk into oblivion. We are always up to date with science news because our channel keeps up with the